Hope you're all enjoying the conference so far. So my name is Savira D'Souza and I'm majoring in cognitive systems. I'm really passionate about applying machine learning to be able to estimate patterns of movement. For today, I'll be talking about my research project, which is looking into the development of infant vocalization and head movement as they're exposed to either music or language. So the aim of our research had two questions in mind. One is whether there's increase in head movement, that is in infants, as they vocalize, and especially if this increase in movement, if there's a significant difference when they listen to either music or to language. So you may ask, why is this important? Why is it important to look into these questions? Well, previous research on adult participants have shown how their auditory speech perception is greatly improved when head movement is accompanied with speech. And also, previous research has shown how we can estimate head movements merely by the acoustic properties of speech itself. And also, do you not notice yourselves that as you talk, you find your head moving? Well, if in case you haven't noticed, you can observe the movement of my head throughout this presentation. So what we aim to do is we aim to carry these findings on adult participants over to infants to see if they're already starting to make this relationship between head movement and vocalization. And this is an important step in beginning to understand this development from infancy to adulthood. So for our research, we used 20 videos of infants that have been exposed to either music or language. And these videos were pre-recorded in the Dr. Janet Worker's Infant Study Center. And they were pre-recorded for previous studies. So as you can see in the image, the infant is placed on the guardian's lap, and the guardian is made to wear headphones. Right in front of the infant is a TV screen which has an image on it. And in this case, the image is a black and white checkerboard. And right underneath the TV, the TV is the camera that is pre-recording the entire experiment. So we use two procedures to acquire data from these videos. One of the procedure is this software called Anvil. So Anvil enables us to identify for different movements in the video. So as you can see in the image, there are these different lines which indicate different movements. For example, arm movement, eye gaze, torso movement, etc. And so these are movements identified for that particular frame in the video. For our study, we identified for vocalization. The other movements were identified for a larger part of the project, and so you can see the vocalization movement where it is identified. A second procedure that we use is called optical flow analysis. And optical flow analysis enables us to measure for the magnitude of movement occurring in the video. And the way it does this is it measures the change in pixel brightness in the video. So the video I'm about to show you, you will observe how the pixels change in brightness. So when there's more movement, the pixels become brighter, and when there's lesser movement, it's less bright. So as you can see how the pixels change in brightness. And I'll just play it again to you so you can see, they're becoming brighter. So what did we do with this data for our analysis? For first step was we defined regions of interest using optical flow analysis, and we defined these regions around the infant's head. So in this way, we could acquire the magnitude of head movement throughout the video. Then, using the vocalization intervals that we identified in Anvil, we could compute the magnitude of head movement that occurred during these intervals. We also defined intervals before and after vocalization, and they were defined for the length of that vocalization interval. So for example, if the baby was vocalizing for 1.5 seconds, The before and after intervals were also 1.5 seconds. Similarly, we could compute the amount of head movement that happened during these intervals as well. And then we compared that head movement before, during, and after intervals. So in this, you can see it more visually in the form of a graph. The x-axis shows the time in seconds. The y-axis shows the amount of head movement. The purple line that you can see is the vocalization interval that we identified in Anvil. The green line is the amount of head movement happening during vocalization. The red line shows the amount of movement before vocalization, and the blue line after vocalization. These are two graphs of two different infants that have been exposed to language. What do our results tell us? What we find is that across all infants, that is those exposed to music and those exposed to language, there's an increase in head movement as they vocalize. The asterisks that you can see in the graph, these show the significant comparisons between intervals. So for both conditions, music and language, there's an increase in head movement at the onset of vocalization. For the infants that have been exposed to language, you can see that there's a decrease in movement right after vocalization. What can we conclude from these results? So because of the increase in head movement that happens during vocalizations, it may suggest to us that infants are putting in extra effort as they vocalize, so extra effort in their head movements. And also we can say that there is a difference when they hear music or when they hear language. In that infants hearing language, there's a decrease in head movement right after vocalization. And this may suggest to us that they're already showing a relationship of head movement and vocalization, which is not so the case with infants that are hearing music. So where do we aim to go from here? So first step is we want to investigate the amount of head movement that's happening during the voice and voiceless vocalizations. So let me just explain what voice and voiceless vocalizations are. So voice vocalization is when you breathe out and it creates a vibration effect. So if you like, you can put your hand over your throat, and if you say zzz, you'll feel it vibrating. So you can do it yourself. And voiceless is just the opposite. It's where you breathe out, but it doesn't create a vibration effect. So just put your hand over your throat and say so you can't feel it. So why look into that? Well, our previous findings show that the infants that hear language, there are more instances of voice vocalizations. And so we want to see if this is an indication of development of head movement and vocalization. We also want to see into other areas of the body other than head movement. And more like, do they move as, is there an increase in movement in them as well during vocalization? So for example, hands. Is there an increase in arm movement? Could this be an indication of gestures, perhaps in infants? And also, we want to see if we can convey linguistic information from the head movements of infants, like we could do with adults. So can we predict head movement merely by the infant vocalization properties? And finally, I would like to thank my supervisor, Dr. Faiz, who guided me and advised me throughout the project and also taught me how to read results. And I'd also like to thank Dr. Bateson and Dr. Barbosa, who let me use the facilities in the Communication Dynamics Lab. And thank you all for listening. So, any questions? Yes.
I probably just missed something, but I'm confused about what your data actually was. So babies were either presented with speech stimuli or music, and then they vocalized in response to that?
Yes, so in the video is supposed to play a sound, but I guess you couldn't hear the sound here. But in the background, they were either listening to a language stimulus or to a music stimulus. So the music was like a flute playing, and the language was just like a woman's voice, which was saying a nonsense word. In the video's case, it was supposed to be like, neeks, and like in baby talk.
Right, and so then in response to that, we saw the baby flapping all around. And
Yeah,
when babies flap
and
all around, do they just naturally say blah, blah, blah? Is that what happens?
Well, in some cases, some of the infants, they said like some words. I don't know what the description for those words are. I guess baby words.
Yeah.
And some of them, there was like, yeah, there was a lot of movement. Yeah, so, but there was a lot of movement more for music than there was for language, except for maybe one or two of the infants. Yes?
I'm just wondering what the overall purpose of this research is. Why is it important to collect data about the infants' head movements?
Well, we wanted to see first, well, with the adult research, we could see this relationship that there is with head movement and speech, and how it's so connected so well. Like you can estimate head movement just by speech properties. And so we want to see like when this starts developing. And so our first step was to see if there was even movement happening during the time. If there was no movement, it was all still, then they couldn't really suggest to us anything. But in this case, we could see there is an increase in movement. And it suggests to us that these infants are putting in some effort. They're trying to converse, maybe, or they're trying to respond to the sounds they hear. And that's like the important step for us before moving ahead.
That's interesting, thank you.
No worries. Yes?
In which direction do you think cause-effect lies? So is it speaking causes your head to move? Or is it if your head moves, it allows you to speak better? Or to learn to speak better?
Well, that's a good question. And I may not be able to answer this with the infant research, but with adults what we found was that when there's head movement accompanied with speech, they could understand it better. But even, they could understand it better than just listening to the speech. So I guess it's difficult with infants because you cannot ask them whether, if they understand what they say. So I guess that's one thing that we could possibly look into the future after we could find out whether there is this important connection.
Are there plans to follow these infants as they progress through development?
Well, one of the steps is to see if they convey linguistic information, and so that's where I'm hoping to apply my interest in machine learning to see if we can predict head movement from their speech, from their vocalizations itself. Yeah. Yes?
You mentioned head movements being indicative of development. Is that true? Like in the thing I remember, you mentioned something about
Well, we said this could maybe a suggestion of a development of the relationship of head movement and vocalization together. So as in terms of language context, because we saw this important relationship only with infants that were exposed to language, and so because we saw it was most significant for them, so we wanted to see if this could be possibly a suggestion of this development, how it transforms to adults and how they show this important relationship as well. Yes.
So you have done, in this one you used a 6-month-old?
Yes,
infant?
so there were 20 infants,
20,
10
okay.
exposed to music and language, and all of them were 6-month-olds.
And have you done it with different age groups in terms of how they kind of progress in their head movement?
Well, in this case, no, because this was part of a larger part of the project, and the larger part of the project had like 14-month-old infants as well. But in this case, we were more interested to see the correlation of head movement from vocals, and because of what the results show, we might also include more infants from different age groups to see if it carries on as well. Yeah. Oh yes.
I was wondering how were the different infants selected? Like, were there any qualities that would cause you to exclude some infants rather than include them?
Well, because these were pre-recorded videos of previous studies, so I may not know how those infants were selected. But so we used those videos from those studies. But in this case, we had to disinclude some of the infants, mainly because of parental interaction with the infants, and we felt like that could bias the results. Like parents interfering with infants could mean the movement doesn't come from the infants necessarily. So in this case, we used infants that were not, where there was not as much parental intervention.
Thank you, Surya.
Okay.